Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling through the multiverse, a place where imagination meets possibility. From the deepest theories of physics to gentle visions of other realities, we'll explore 100 sleepy facts to help you relax, unwind, and dream of infinite worlds. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. The idea of many worlds. Long before we ever whispered the word multiverse, people gazed at the night sky and wondered if this world was the only one. The thought drifted quietly through ancient minds, the possibility that beyond our familiar stars, other realms might glow softly in the dark. Even without telescopes or equations, there was a sense that reality might be larger than our eyes could ever see. Today, physicists describe the multiverse as a tapestry of countless universes, each one shaped by different conditions, different histories, different gentle beginnings. Like bubbles floating in a vast cosmic sea, they drift quietly, never touching, never disturbing one another. It's a simple idea with endless depth that our universe might be just one note in a much larger cosmic song. And from that first wondering, more questions begin to unfold. Fact 2. Ancient echoes of infinite realms. The dream of multiple worlds is older than science itself. Ancient philosophers in Greece, India, and China each imagined realms beyond our own places, where nature repeated itself or unfolded in entirely new ways. Some envisioned infinite space, stretching without end. Others pictured layered worlds, stacked like gentle pages in a cosmic book. Though their ideas were shaped by myth and poetry, the spirit behind them feels familiar. A quiet curiosity, a soft human longing to understand our place in something bigger. They didn't speak of dimensions or particle fields, but they sensed the vastness, the possibility that reality could hold more than one story. In their words, we hear the earliest echoes of multiverse thinking, distant, hopeful murmurs from minds that looked up and dreamed. And as time moved forward, new voices would join that dream. Fact 3. The quiet rise of modern multiverse. Theory. Modern multiverse ideas began not with science fiction, but with careful mathematics and gentle questions about how the universe began. As cosmology grew more detailed, theories emerged, suggesting that our universe might not be unique, that its laws, its forces, even its shape could be the result of a particular cosmic roll of the dice. Physicists noticed that tiny changes in the early universe could have produced entirely different realities. Some models hinted that inflation, the rapid swelling of space after the Big Bang, might naturally produce countless universes, each sealed within its own bubble of space-time. It was no longer just imagination. It became a quiet scientific possibility. And beyond that possibility, the multiverse begins to unfold even further. Fact 4. The universe as a cosmic bubble. Our universe, vast as it feels, may be nothing more than one delicate bubble in a far larger cosmic sea. Imagine space-time stretched thin like a shimmering film, curving gently around us, holding everything we know about every star, every galaxy, every quiet moment of existence. In multiverse models, countless bubbles like ours float side by side, each sealed in its own pocket of reality. Inside one bubble, physics may hum exactly as we know it. Inside another, the rules might drift in softer or stronger directions. These bubbles rarely meet, drifting apart as the sea around them expands. It's a peaceful image of reality, not as a single container, but as a collection of floating worlds. And just beyond our bubble, another may be forming even now. Fact 5. The inflationary whisper. The reason these bubble universes might exist begins with something incredibly gentle, a whisper of inflation. Right after the Big Bang, space didn't simply expand. It swelled with unimaginable speed, like a breath of air filling a silent balloon. This inflation happened unevenly, creating pockets where the rapid stretching slowed, allowing universes like ours to settle and cool. But beyond those calmer pockets, inflation continued. It kept unfolding space, creating new regions where fresh universes could blossom in their own time. Physicists call this eternal inflation, a process that never quite stops, always leaving room for new cosmic bubbles to appear. It's a picture of creation that feels surprisingly soft, a quiet blooming rather than a single explosive birth. And from that bloom come the many stories of many worlds. Fact 6. Quantum branching paths. While cosmic inflation paints one picture of the multiverse, quantum mechanics offers another one that unfolds on a much smaller, gentler scale. In the quantum world, particles can exist in multiple states at once, like overlapping possibilities waiting to be chosen. When a measurement is made, the system seems to decide, but in one interpretation, nothing is lost. Instead, every outcome lives on in its own branch of reality. In this view, the universe doesn't split with a violent tear. It unfolds like a branching river, each turn quiet, smooth, and natural. Every decision, every chance event, every flicker of probability leads to softly diverging paths. It's a reminder that multiplicity might not only exist on cosmic scales, it may lie in every moment. And from those branches, endless realities continue to flow. Fact 7. The landscape of possibility. In modern physics, the multiverse is sometimes pictured as an enormous landscape, not of mountains and valleys, but of possible universes. Each point in this vast conceptual terrain represents a different way the laws of nature could have settled a different balance of forces, a different whisper of energy, a different cosmic personality. Some regions might be bright and lively, filled with stars and chemistry. Others could be quiet expanses where almost nothing forms at all. The landscape is so broad, so gently varied, that our universe becomes just one small clearing within it, a familiar patch amid countless unseen possibilities. And somewhere across that landscape, other clearings glow softly in the dark. From this, the idea of hidden dimensions begins to unfold. Fact 8. Dimensions beyond sight. Though we move through length, width, height, and time, many theories suggest that reality holds more dimensions than we can sense. These extra dimensions aren't wide open like the space above us. Instead, they may be curled tightly, folded into shapes too small and subtle for light to reveal. If they exist, they could influence the universe quietly, shaping particles, forces, and the gentle behavior of gravity. Some physicists imagine these hidden dimensions like tiny ferns rolled up for sleep, resting at every point in space. Others see them as delicate loops, woven into the fabric of the universe. We don't notice them in our daily lives, but their presence could help explain why our universe behaves with such calm regularity. And beyond those unseen folds lies the limit of what we can observe. Fact 9. The boundaries of our cosmic horizon. Even within our own universe, there is a horizon we cannot cross, a quiet boundary set by the speed of light and the age of cosmic expansion. Light from regions too far away will never reach us, no matter how long we wait, because space itself stretches faster than those photons can travel. Beyond this horizon, entire galaxies drift in darkness, forever out of view. This doesn't mean they aren't real. It simply means they exist in silence, unreachable, but still part of our cosmic family. To us, they are like distant rooms in a house whose doors will never open. Some thinkers wonder, if parts of our own universe lie forever unseen, how many other universes might rest just beyond that final boundary? And with that thought, the wonder of infinity grows a little deeper. Fact 10. Why infinity is so comfortingly strange. Infinity can seem overwhelming at first, but when we approach it gently, it becomes something surprisingly calming. Rather than a number or a destination, infinity is more like a quiet openness, a reminder that reality doesn't need to end sharply at the edge of what we know. In the multiverse, infinity appears not as a threat, but as a soft possibility, endless worlds, endless stories, endless ways for matter and energy to arrange themselves. This boundless nature means there's room for every variation, every delicate shift, every peaceful unfolding of a universe. Nothing needs to be the only way. Everything simply is. And in that vastness, our little world feels precious, like a tiny lantern glowing in the dark. From this comfort, we drift back down into the quantum realm once more. Fact 11. The soft split of quantum decisions. In the quantum picture of the multiverse, reality doesn't erupt into chaos. It branches quietly, like a tree growing new limbs in the night. Every time a particle faces multiple possible states, the universe gently unfurls into versions where each possibility becomes real. This split isn't a violent break. It's a natural expansion of what might happen, woven into the mathematics of quantum behavior. Imagine a calm river dividing into two streams. Each flows peacefully, carrying its own future, its own story. Quantum branching works in much the same way. At every scale, possibilities move forward on their own paths, never colliding, never erasing one another. And so, hidden beneath every decision, the universe becomes a garden of unfolding outcomes. From these branching waters, particles begin their quiet dance. Fact 12. Particles, dancing in many directions. At the smallest scales, particles don't behave like tiny solid beads. They behave more like soft waves of probability, spreading gently through space. A single particle can move left, right, forward, or nowhere at all at once, until something nudges it into a definite path. In the many worlds picture, each possible motion becomes real in its own universe, like dancers stepping onto different stages. It's a graceful process, one that turns uncertainty into structure. Every shift, every subtle motion, every quantum possibility becomes part of a delicate tapestry stretching across countless realities. Though we can only witness one strand, the others continue quietly in their own directions. And from these wandering particles, the story of probability continues to bloom. Fact 13. The faint trail of probabilities. In the quantum world, every particle carries a soft cloud of possibility around it, a faint trail showing all the places it might be. This isn't a physical mist, but a gentle mathematical haze, like the blurred suggestion of footprints on a foggy morning. Until something interacts with the particle, its true path remains quietly uncertain, held in a shimmering balance of potential outcomes. In multiverse interpretations, each of those outcomes becomes the seed of a new reality, each following its own calm storyline. The particle doesn't choose one path over another. Every path unfolds somewhere, softly and peacefully. It's a reminder that even uncertainty can be beautiful, a quiet openness built into the heart of nature. And as we follow that haze, we meet the role of the observer. Fact 14. The observer's gentle influence. For all its mystery, the observer's role in quantum mechanics doesn't need to feel dramatic. Observing a system simply means interacting with it, shining light on it, touching it with a particle, making a gentle measurement. This interaction nudges the system into a definite state, like a soft hand guiding a drifting leaf toward the ground. In everyday life, we barely notice these transitions. They happen constantly and quietly. But in multiverse thinking, each interaction creates a divergence. One branch where the leaf lands here, another where it falls a little to the left, still another where it catches a breeze and drifts farther away. The observer doesn't force the universe into one outcome. The observer just becomes part of the unfolding. And through this shared unfolding, even distant particles remain connected. Fact 15. Entanglement. Across silent worlds, entanglement is one of the most delicate wonders of quantum physics, a link between particles that persists no matter how far they drift apart. When two particles become entangled, their states reflect one another perfectly, as if they share a quiet conversation across space. Measuring one instantly tells you something about the other, even if it's resting on the far side of the cosmos. In a multiverse view, this connection can extend across branching realities too. Each universe carries its own version of the pair, each mirroring the same pattern of correlation. It's less like a message being sent, and more like a graceful symmetry woven through many worlds at once. Entanglement reminds us that even in the vastness, things can remain beautifully connected. And from that connection, we drift toward the soft process of decoherence. Fact 16. Quantum decoherence as a quiet drift. Decoherence is a gentle process, far softer than its scientific name suggests. It happens when a delicate quantum system interacts with its surroundings, with air, with light, with the faint warmth of the world. Those interactions cause the system's overlapping possibilities to drift apart, settling into more familiar, classical behavior. It's like a mist, gradually separating into individual droplets as morning sunlight touches it. Rather than collapsing abruptly, the quantum state slowly loses its ability to stay in many conditions at once. In multiverse thinking, each of those conditions still continues, but in different branches that no longer speak to one another. Decoherence is the quiet boundary where the strange becomes familiar, and just beyond that boundary, superpositions begin to shimmer. Fact 17. Superpositions like overlapping dreams. A superposition is one of the most magical ideas in quantum physics. The notion that something can be in multiple states at the same moment. A particle can be here and there, moving and still, shining and dim, like overlapping dreams, drifting through one another in the dark. Only when something touches the system does it gently choose a path. In the multiverse interpretation, each of these dreamlike states becomes real in its own unfolding world. None is more correct than another. Each simply represents a different thread of reality. The particle doesn't decide, all possibilities bloom quietly, each in its own universe. It's a humbling reminder that nature embraces complexity with grace. And from these overlapping dreams emerges a grand interpretation of reality. Fact 18. The many worlds. Interpretation. Unfolding. The many worlds interpretation, proposed by Hugh Everett, suggests that the universe never collapses its possibilities. It expands them. Every quantum event splits into branches, each carrying forward a complete version of reality. These branches don't clash or compete. They exist alongside one another, like countless soft pages in a book too large to ever hold in our hands. In this view, the universe isn't a single timeline, but a vast, branching tree of outcomes, stretching quietly into the infinite. Each branch feels complete and natural from within, even though it is only one of many. Many Worlds removes the mystery of collapse and replaces it with a peaceful unfolding, a gentle acceptance that reality can hold more than one truth. And from that unfolding, every outcome finds its own home in the vast multiverse. Fact 19. Where all outcomes find a home. If every possibility unfolds somewhere, then nothing is ever truly lost. In the many worlds view, each potential outcome, each flicker of quantum chance drifts gently into its own branch of reality. A particle's motion, a star's formation, even the smallest choices made by living beings, each find a quiet home in their own version of the universe. It may seem overwhelming, but the idea carries a deep, soothing reassurance. Every path has a place to exist. Nothing is wasted, and nothing is erased. The multiverse becomes a vast, welcoming landscape where all stories can unfold peacefully. In this vision, the cosmos feels generous, roomy enough for every possibility, graceful enough to allow them all to breathe. And with that generosity in mind, we drift back to the beginning of everything. Fact 20. The calm logic behind possibility. The multiverse may feel like a dreamy idea, but its roots lie in the calm logic of physics. When equations suggest multiple outcomes, the simplest explanation may be that all are realized in different ways. Instead of constraining nature to choose just one, the multiverse allows the laws of physics to play out their full range of possibilities. This perspective brings a quiet clarity. Rather than imagining a universe finely tuned to one perfect outcome, we can picture countless universes, each shaped by slightly different starting conditions. Our universe becomes just one gentle note in a larger mathematical melody. Nothing extravagant is required, only the acceptance that nature may be broader, softer, and more varied than our senses reveal. And with this mathematical calmness, we step into a new picture of creation. Fact 21. The first breath of inflation. To understand how whole universes might arise, we return to the earliest moment after the Big Bang, a time when space expanded with unimaginable speed. This burst of rapid growth is called cosmic inflation, and in many models, it offers the first gentle step toward a multiverse of bubble universes. During inflation, space didn't stretch evenly. Some regions slowed down and cooled, becoming calm enough for stars and galaxies to one day form. Other regions continued expanding wildly, racing outward like rolling waves. In these endlessly expanding areas, new universes could bloom, each sealed off from the others by vast distances. Inflation feels less like an explosion and more like a quiet, unstoppable breath that continues to this day. creating pockets of reality across the cosmic sea. And from that breath, the bubbles of the multiverse begin to rise. Fact 22. A sea of expanding bubbles. If inflation is a gentle breath, then the multiverse it creates can be imagined as a vast sea filled with ever-expanding bubbles. Each bubble is a universe, separated from the others by distances so immense that even light could never cross the divide. These bubbles don't collide or blend. They drift apart endlessly as space itself stretches wider and wider. Inside each bubble, the laws of physics settle into their own quiet patterns, giving rise to galaxies, stars, and the slow unfolding of cosmic time. Some universes may be rich with structure like ours, while others might remain smooth and almost featureless. It's a peaceful image of an infinite ocean where each bubble glows faintly with its own story. And just beyond one bubble lies another, born from the same gentle expansion. Fact 23. Universes that never touch. In many multiverse models, the bubbles created by eternal inflation are forever isolated. Once formed, they drift away from one another faster than any signal could ever travel. Even if two universes floated side by side, the space between them expanded so swiftly that they could never share energy, matter, or light. They remain silent neighbors, visible to no one within them. This separation isn't cold or lonely. It's simply the nature of cosmic expansion. Each universe becomes its own quiet island, with its own flow of time and its own unfolding history. We can imagine countless such islands, drifting outward into a sea of endless potential. Their isolation gives each universe the freedom to grow gently in its own way. And as they drift, the laws within them may shift softly as well. Fact 24. Regions where physics shifts. Softly. One of the most intriguing ideas in the inflationary multiverse is that each bubble universe may settle into a slightly different version of physical laws. The strengths of forces, the behavior of particles, even the way space curves could vary gently from one bubble to the next. These differences arise from the way energy fields cool and stabilize as each universe forms. In our bubble, conditions happen to settle into a delicate balance that allows stars to shine and planets to form. In others, gravity might be lighter, or atoms might cling together more tightly, shaping worlds unlike anything we can imagine. These soft shifts in physics don't break the laws of nature. They simply express different facets of them. And from each unique balance, new cosmic possibilities begin to bloom. Fact 25. The edges of other cosmic foam. If we could hover outside our universe like a quiet observer, floating in higher dimensional space, we might see countless universes forming a delicate foam. Each bubble nestles against the vastness, its edges shimmering where space-time curves inward. Though the bubbles never touch, their presence forms a tapestry of soft, glowing spheres, each wrapped in its own boundary of expanding space. These cosmic edges are not hard walls, but gentle transitions, where the shape of space changes so rapidly that nothing can cross from one bubble to the next. From afar, the multiverse might resemble a cluster of dewdrops resting calmly on a leaf, each reflecting different cosmic possibilities. And from these edges, new universes continue to appear like morning light spreading across a field. Fact 26. Where new universes bloom. Like dewdrops. In eternal inflation, new universes form continually, emerging in regions where space is expanding fastest. These newborn universes begin tiny, smaller than particles, smaller than atoms, but they grow astonishingly quickly as inflation slows within them. It is as if creation happens in countless little bursts, each one giving rise to a fresh bubble of reality. These births are not loud or violent, but gentle transitions, where high energy fields settle into calmer states. As they do, the fabric of space stretches and cools, allowing time, particles, and eventually stars to take shape. Across the multiverse, this blooming happens endlessly. Universes rise like dewdrops on an infinite morning, each one carrying a unique set of conditions and a quiet potential for wonder. And within these dewdrops, even the emptiest regions hide surprising depth. Fact 27. Vacuum fluctuations stirring creation. At the heart of many multiverse ideas lies a simple but beautiful truth. Even in what we call empty space, energy is never truly still. Tiny fluctuations ripple through the vacuum, appearing and disappearing in delicate rhythms. In most places, these ripples are harmless whispers, too small to form anything lasting. But in the extreme conditions of early cosmic inflation, a single fluctuation could be amplified into something enormous. A tiny rise in energy can swell into a newborn universe, its space stretching rapidly until it becomes an entirely separate realm with its own physics and future. It's astonishing to think that something as small as a whisper of energy could give rise to everything: stars, galaxies, life. And from these fluctuations, the story of cosmic creation quietly continues. Fact 28. False vacuums and gentle falls. In some theories, the universe began in a state known as a false vacuum, a high-energy condition not entirely stable, like a ball resting on a shallow plateau rather than the lowest valley. Over time, this state can gently roll into a truer, calmer vacuum. When that shift happens, space itself transforms, creating a bubble of new reality that expands outward at incredible speed. This transition is often described in dramatic terms, but in the multiverse, it becomes something softer, a natural, graceful settling of energy fields into more peaceful states. Each shift forms another bubble universe, each one a fresh start written into the fabric of existence. The false vacuum doesn't collapse violently. It simply relaxes, like a deep exhale after a long breath. And from this quiet fall, endless universes find their beginnings. Fact 29. The eternal nature of inflation. Eternal inflation suggests that while some universes slow down and cool, the overall expansion of the multiverse never stops. In certain regions, inflation continues endlessly, stretching space faster than any particle could ever travel. These regions act as fertile ground for new universes, constantly budding off like blossoms in an infinite cosmic garden. This ongoing process means the multiverse has no single beginning and no final boundary. It grows gently, forever pushing outward into new possibilities. While our own universe experiences calm and aging, other universes are just beginning their first glimmers of structure. It's a serene idea. Creation not as a one-time event, but as a continuous, quiet blooming through eternity. And from this endless blooming comes the unique home we inhabit, one calm pocket among many. Fact 30. Our universe as one. Quiet pocket. Amid this vast, endlessly expanding landscape, our universe is just one tranquil region where inflation slowed enough for familiar physics to take shape. In this pocket, energy settled into stable forms, allowing particles to bond, stars to ignite, and galaxies to drift into their elegant spirals. Everything we see, every sunrise, every atom, every soft breath comes from the delicate balance that settled here. Other pockets may be warmer or cooler, smoother or more chaotic, But our universe found a gentle equilibrium, a set of conditions hospitable to complexity and life. It floats in the multiverse like a small lantern glowing in an ocean of possibilities. And from our quiet pocket, we can begin to explore realities shaped by deeper dimensions. Fact 31. The whisper of tiny, vibrating strings. String theory suggests that everything in the universe, every particle, every force, every quiet shimmer of energy may arise from tiny vibrating strings. These strings are unimaginably small, far beyond the reach of any microscope, yet their subtle vibrations could give rise to the familiar particles we see. A gentle tremor corresponds to one particle, a different vibration to another, like musical notes forming the harmonies of nature. In a multiverse shaped by string theory, different universes might settle into different vibrational patterns. Each universe becomes its own soft symphony, defined by the rhythms humming through its hidden strings. It's a poetic idea that all of reality might be built from music too small for us to hear. And from these quiet strings arise dimensions curled out of sight. Fact 32. Dimensions curled like sleeping ferns. String theory doesn't work in just 3 spatial dimensions. It requires many more. These extra dimensions aren't wide open like the space we move through. They are curled tightly into intricate shapes, folded so delicately that we can't see or touch them. Physicists imagine these shapes as complex geometric forms, coiled like tiny sleeping ferns resting at every point in space. If these curled dimensions unfolded, the universe would look entirely different. The forces acting on particles, the strength of gravity, even the structure of atoms might shift in surprising ways. But because the dimensions remain tucked away, they influence our world subtly, shaping physics from the shadows. These hidden folds of space may vary from universe to universe, each giving rise to different cosmic personalities. And from those folded dimensions come expansive structures called brains. Fact 33. Brains, drifting through higher space. In some string theory models, our entire universe resides on a vast, multidimensional surface called a brain. You can imagine a brain as a floating sheet, drifting gently through a higher dimensional space known as the bulk. Everything we see, stars, galaxies, the quiet glow of cosmic dust, is tied to this brain, unable to drift away from it. Other brains may drift nearby, each holding its own universe with its own laws of physics. Though impossibly close in higher dimensions, their contents remain completely separate, like paintings on different canvases that never touch. The multiverse becomes a gallery of cosmic sheets, each moving calmly through the quiet halls of higher reality. And in those halls, whole universes can meet, separate, or even collide in slow, graceful ways. Fact 34. Universes resting on cosmic sheets. If our universe is a brain, then it rests like a vast cosmic sheet, smooth, expansive, and gently curving through higher dimensional space. Everything we know is confined to this surface. Light, matter, and the familiar forces of nature move along it, like patterns woven onto a tapestry. To us, this brain feels complete and three-dimensional, but from a higher vantage point, it may be only one layer among many. Other brains may lie close by, parallel, but unreachable, each carrying its own stars and galaxies. They drift like calm sails on a still ocean, never touching, never revealing themselves. Yet their quiet presence hints at a structure far grander than our senses can perceive. From these layered sheets, a deeper story of cosmic births begins to unfold. Fact 35. Colliding brains as birthplaces of light. In some models of the multiverse, universes begin not with a single Big Bang, but with the gentle collision of two brains. When these immense surfaces brush together, their stored energy may ignite into a burst of heat and light, enough to create a newborn cosmos. The collision doesn't need to be violent. In higher dimensions, even a soft touch can release vast amounts of energy. This idea reimagines our Big Bang as one moment in an ongoing dance between brains drifting through the bulk. After the collision, the brains separate again, gliding away in silence while the new universe expands and cools between them. It's a peaceful picture, creation not as chaos, but as a delicate meeting between cosmic sheets. And within those sheets, hidden geometric shapes begin to play their own quiet role. Fact 36. Calabi-Yau shapes, hidden in the dark. To make sense of the extra dimensions in string theory, physicists use intricate geometric forms called Calabi-Yau manifolds. These shapes are far too tiny to see, curled up at scales much smaller than atoms, but their structure determines how strings vibrate, and therefore how particles behave. Each possible shape gives rise to a different physics, a different melody of forces and particles. In the multiverse, countless Calabi-Yau shapes may exist, each producing a distinct kind of universe. Some shapes allow galaxies to form. Others might create universes filled with only simple particles or faint fields of energy. These curled forms rest in utter darkness, untouched and unseen, yet they shape everything we know. And from this vast range of shapes emerges an immense landscape of possible realities. Fact 37. The string landscape of 10^500 realms. One of the most astonishing ideas in string theory is the sheer number of possible universes it allows. Depending on how the tiny Calabi-Yau dimensions fold, twist, and vibrate, the laws of physics can take on an incredible variety of forms. Physicists estimate that there may be around 10^500 distinct possible configurations, a number so vast it stretches beyond imagination. Each configuration corresponds to a different vacuum state, a different set of fundamental rules. Some might give rise to universes filled with stars and chemistry. Others might create realms too simple or too exotic for familiar structures to form. This collection of possibilities is called the string landscape. It's a reminder that our universe may be just one quiet note in a near-endless symphony. And within that symphony, gravity plays a particularly gentle role. Fact 38. Gravity, wandering into other dimensions. Gravity is the most mysterious of the fundamental forces, and in some theories, it behaves differently from the others because it can drift into higher dimensions. While light, electromagnetism, and nuclear forces are confined to our brain, gravity may spread softly into the surrounding bulk, becoming diluted across many dimensions. This could explain why gravity feels so weak compared to other forces. In universes with different dimensional shapes, gravity might be stronger or weaker, shaping entirely new kinds of cosmic structures. Stars could burn more brightly, galaxies could form differently, or planets might never stabilize at all. The idea that gravity can wander beyond our universe adds a quiet elegance to the multiverse, a suggestion that some forces move with more freedom than we can perceive. And from these hidden wanderings emerges a vision of deeper symmetry. Fact 39. The quiet strength of supersymmetry. Supersymmetry, often called SUSY, is a theoretical symmetry that pairs every known particle with a yet undiscovered partner. These partner particles are heavier, quieter, and more elusive, hiding in energy ranges we have not yet reached. If supersymmetry exists, it could help explain why the universe feels so balanced and why forces behave gently enough to allow stable matter and long-lived stars. In the multiverse, some universes may exhibit perfect supersymmetry, while others may break it in subtle ways. Each pattern leads to different cosmic outcomes, different particles, different stars, different paths for matter to evolve. Supersymmetry adds a soft sense of order to the multiverse, a hidden harmony beneath the visible world. And from these hidden harmonies flows the mystery of higher dimensions that remain unseen. Fact 40. Why higher dimensions stay out of sight? If higher dimensions truly exist, they hide themselves with remarkable subtlety. They may be curled so tightly that even the shortest wavelengths of light cannot slip inside to reveal them. Or they may be arranged in delicate geometric folds that allow particles to feel their influence without ever exposing their shape. To us, these dimensions are silent companions, shaping the universe from behind a curtain we cannot lift. Their presence helps explain why forces behave as they do, why particles take on certain masses, and why space feels three-dimensional, even though deeper layers sit just beyond reach. They remain unseen, not because they are absent, but because they rest in forms too small and quiet for our senses. And from these unseen dimensions, the idea of parallel realities softly takes shape. Fact 41. Mirror realities with gentle differences. Parallel universes need not be wildly different from our own. In some multiverse ideas, mirror realities exist that are almost identical. Same laws, same structures, nearly the same history, but with small, soft differences that branch quietly over time. A star may form a little earlier. A storm may drift slightly off its usual path. A choice may lean one way instead of another. These differences ripple forward gently, shaping worlds that feel familiar, yet subtly altered. In a mirror universe, Earth might orbit the Sun just a little closer or spin a touch slower, changing seasons and tides in delicate ways. Imagining these twin realities brings a sense of calm, a recognition that even small variations can create entirely new worlds. And beyond these mirrors lie universes even more closely tied to our own. Fact 42. Parallel Earths, drifting side by side. If the multiverse contains countless universes, then some of them may resemble our own so closely that they feel like quiet echoes. These parallel Earths could have similar landscapes, similar oceans, and similar skies shaped by the same physics, but slightly different histories. On one Earth, a forest may stretch farther north. On another, a river may carve a new path through ancient stone. Life might evolve in familiar patterns, guided by the same gentle forces of biology. Cities may rise in slightly different places. Cultures may unfold in new directions, and the night sky might feature constellations just a little shifted from our own. These parallel Earths drift in silence, never touching, never sensing one another, yet coexisting peacefully across the multiverse. And from these small differences, the flow of choices begins to ripple outward. Fact 43. Choices echoing through infinite rooms. In a multiverse shaped by branching paths, every choice becomes a quiet doorway. When a possibility appears, reality doesn't force a single outcome instead. It gently opens many rooms, each containing a different version of events. A step taken or not taken, a word spoken or left unsaid, a turning of the wind at just the right moment. Each creates a new thread of reality. These echoes are not loud or dramatic. They're soft expansions of possibility, unfolding like ripples on a still lake. every choice continues forward in its own peaceful direction, forming a vast network of intertwined stories. In this view, our lives become constellations of gentle moments reflected across countless worlds. And beyond those echoes, history itself begins to drift along different currents. Fact 44. Worlds where history took softer turns. In some parallel universes, history may unfold almost exactly as it did here, but with small, tender shifts. A discovery might happen sooner or later. A peaceful agreement might replace a conflict. A quiet innovation could lead a civilization down a slightly different path. These soft differences accumulate over time, reshaping the world in ways both subtle and profound. Imagine a universe where a desert blooms because rains fell more often centuries ago, or one where a forgotten coastline became the cradle of early exploration. Cultures evolve with their own gentle rhythms, guided by the same human curiosity but carried along different historical winds. These softly altered histories remind us how delicate the balance of events can be. And beyond the familiar, more mysterious worlds drift in deeper shadows. Fact 45. Shadow worlds we'll never reach. Among the many possible universes, some may be so different from our own that they feel like quiet shadows, places ruled by unfamiliar physics, unusual matter, or rhythms of time that bear little resemblance to ours. These worlds might not contain stars or planets as we know them. They might shimmer with exotic particles, or unfold so slowly that nothing recognizable ever forms. Though we can imagine them, we will never touch or observe these shadow universes. They remain sealed behind the barriers of their own laws, existing in silent parallel to our reality. Yet their existence adds depth to the multiverse, showing that possibility stretches far beyond our intuition. These unreachable worlds highlight the quiet mystery of existence. And from that mystery, the idea of cosmic twins softly emerges. Fact 46. Cosmic twins born from chance. In the vastness of the multiverse, some universes may begin with conditions so similar to ours that they become cosmic twins, nearly identical in their earliest moments, shaped by the same gentle balance of forces. But even the tiniest fluctuation, a difference too small for us to imagine, can eventually send these twins down subtly diverging paths. A star might ignite a little earlier. A galaxy might drift a little farther. A planet may cool more slowly under a slightly altered glow. These changes ripple forward over billions of years, turning two nearly identical beginnings into distinct and quiet stories. The twins remain connected only by their shared origin, like siblings who grow in different homes but remember the same first light. And from those small variations comes the beauty of endless differences. Fact 47. The beauty of slight variations. One of the most comforting ideas in the multiverse is that tiny differences can create entire worlds. A slightly stronger pull of gravity, a whisper more heat in the early universe, or a faint shift in the speed of expansion could reshape everything from the brightness of stars to the chemistry of life. These variations don't need to be dramatic to matter. A galaxy might form with more spiral arms, or with none at all. A world might cradle oceans under a deeper sky, or drift barren through a quiet void. Each small change paints a new portrait of reality, delicate and unique. In this way, the multiverse becomes a library of subtle possibilities, each universe a variation on a cosmic theme. And among these variations, reflections of ourselves quietly appear. Fact 48. Reflections of ourselves in other paths. If parallel Earths exist, then among them might be versions of us shaped by slightly different circumstances. Not perfect copies, more like gentle reflections, altered by different choices, different experiences, or different histories unfolding around them. A version of you might have learned a different skill, met different people, or followed a quieter or braver path. These reflections aren't competitors or shadows. They're simply other expressions of possibility, shaped by the same curiosity and the same spark of consciousness carried along new currents. In the multiverse, identity becomes a soft, branching river, flowing in many directions while still feeling deeply familiar. These imagined reflections remind us that who we are is only one of many ways a life can unfold. And from these branching selves, the quiet future begins to diverge in countless ways. Fact 49. Alternate futures. Branching. Quietly, every moment carries within it countless possible futures, like unopened petals on the edge of blooming. In the multiverse, these futures don't vanish when one path unfolds. They continue gently along their own separate streams, forming universes where events follow different rhythms. Some futures may be bright and bustling, others calm and contemplative, each shaped by the smallest shifts in chance or choice. These branching futures drift outward like tiny lanterns on a still river, each glowing with its own timeline. Some may mirror our own closely, others may wander far from anything we can imagine. Yet all are natural expressions of possibility, unfolding softly in the dark. And beyond these branching tomorrows lies the idea of worlds hidden just out of sight. Fact 50. Why parallel worlds remain hidden. If parallel universes exist, they remain forever beyond our reach. This isn't because they are hostile or distant, but because the fabric of space-time keeps each universe sealed within its own boundary. Light cannot cross the divide. Gravity cannot bridge the gap. Even the boldest signals we could imagine sending would fade before they ever touched another reality. These boundaries are not like walls. They're more like the gentle limits of a dream. You can sense the possibility of other stories, but you cannot step into them. Each universe simply follows its own path, untouched by the countless others drifting in the multiverse. This quiet separation gives every universe its own space to breathe, to grow, and to unfold its unique story. And from this isolation, we turn to the deeper structure of universes themselves. Fact 51. The shape of space in other universes. Space has a shape, even if it's hard to feel. In our universe, it may be flat and calm, stretching smoothly in all directions. But in other universes, the shape of space could curve gently inward, like a closed sphere, or outward, like an endless saddle. These differences arise from the way energy fills each universe, shaping its geometry like a potter shaping clay. A universe with curved space might guide galaxies into unfamiliar patterns or bend the paths of light in subtle, beautiful arcs. One with flatter space might feel more open, allowing structures to spread widely across the cosmos. Each universe becomes a unique artwork of geometry, painted by the quiet balance of matter and energy that fills it. And from these varied shapes flow new possibilities for the laws that govern them. Fact 52. Physics, rewritten in distant realms. In the multiverse, the laws of physics may vary from universe to universe, shaped by the delicate conditions present at each one's birth. A different balance between forces could change everything. The way atoms hold together, the brightness of stars, even the flow of time itself. In some realms, matter might cling tightly, forming dense, shadowy worlds. In others, particles might barely connect, creating vast, airy universes where structure is rare. These changes aren't chaotic. They're simply alternate expressions of the same cosmic principles, much like different songs played on the same instrument. Each universe follows its own set of rules, unfolding its story in a calm, natural way. The diversity of physics across the multiverse becomes a whispered reminder that there is no single way for reality to be. And from these changing laws, new kinds of stars begin to glow. Fact 53. Stars forming under different rules. In our universe, stars form when gravity gathers gas and dust into dense clouds, lighting them with nuclear fire. But in a universe with different physical constants, stars could ignite in unfamiliar ways, glowing dimly with cooler reactions, or blazing fiercely with energy far beyond our experience. Their colors might drift into softer blues or deeper reds. Their lifespans could stretch for trillions of years or flicker out in mere moments. These alternate stars would shape everything around them. Planets might orbit closer or farther, warmed by unfamiliar light. Solar winds could be gentler or stronger, sculpting alien systems with quiet determination. Even though we'll never see them, the idea of stars forming under new rules paints a peaceful picture of variety woven into the cosmos. And around these strange stars, galaxies spin in different patterns of grace. Fact 54. Galaxies spinning with new patterns. Galaxies are shaped by the forces at play in their universe: gravity, dark matter, cosmic expansion. Change any of these even slightly, and galaxies could form entirely new structures. Some universes might host delicate spiral arms far more tightly wound than ours, curls of stardust wrapped like gentle ribbons. Others might give rise to vast, luminous clouds without any recognizable shape, drifting softly in the dark like cosmic fog. In worlds where gravity is stronger, galaxies may clump into dense, glowing spheres. Where it is weaker, they may stretch into sprawling lace-like webs. Each variation creates its own quiet beauty, its own rhythm of stars drifting through time. These alternate galaxies remind us that even on the grandest scales, the universe can be endlessly creative. And beyond these swirling patterns lie worlds lit by very different kinds of light. Fact 55. Worlds without familiar light. In some universes, light as we know it might not exist at all. If the electromagnetic force behaved differently, atoms might not release photons in the same gentle waves we depend on. Instead, these worlds could glow with unfamiliar forms of energy, perhaps faint neutrino glimmers, or soft fields that ripple without illuminating the dark. Planets might never experience a sunrise, and galaxies might drift as quiet silhouettes against a canvas of deeper night. Life, if it arose, would adapt to other senses, other rhythms, other forms of awareness. Creatures might navigate by magnetic veins, or by subtle pressure gradients in the air, or by sensing tiny ripples in exotic fields. Even in the absence of traditional light, the cosmos would still have its own quiet ways of expressing beauty. And from such worlds, we consider how atoms themselves might behave differently. Fact 56. Atoms behaving in softer ways. Atoms are the building blocks of everything, but their behavior depends on a delicate balance between forces. Change the strength of the electromagnetic force, and their sizes may shrink or swell. Adjust the mass of particles, and their bonds may loosen or tighten. In other universes, atoms could be fragile things that barely cling together, or incredibly robust structures that form dense, unusual materials. These altered atoms would create chemistries far removed from our own. Crystals might grow in unexpected patterns, liquids might shimmer with otherworldly motions, and gases could flow more like silk than air. Even simple elements could take on new personalities, guiding the evolution of landscapes and life in surprising directions. It's peaceful to imagine matter whispering its own rules in each universe. And from shifting atoms emerge the varied influences of dark energy. Fact 57. The quiet role of dark energy. Variations. Dark energy is the mysterious force that drives the expansion of our universe. In a multiverse, its strength might change from one cosmos to another, altering the growth of space in subtle or profound ways. If dark energy were stronger, galaxies might drift apart so quickly that stars barely had time to form. If it were weaker, gravity might draw everything together more tightly, filling the sky with dense, brilliant clusters. These variations create entirely different cosmic moods. A universe with gentle dark energy may feel spacious and calm. One with intense dark energy may feel light and fleeting, with structures dissolving almost as soon as they appear. In each case, the universe follows a quiet rhythm set by the balance of forces within it, and from those rhythms arises gravity's shifting personality across worlds. Fact 58. Gravity's personality in other realities. Gravity may seem simple here, a soft pull that shapes planets, guides moons, and gathers the stars. But in other universes, its personality could shift in subtle ways. If gravity were a touch stronger, matter might collapse more quickly into bright, short-lived stars. If it were gentler, clouds of gas might drift for ages, forming vast, diffuse structures rather than dense galaxies. These variations could create universes that feel either tightly knit or quietly expansive. In some places, gravity might encourage elegant spirals of starlight. In others, it might allow delicate cosmic webs to stretch across enormous distances. Each version of gravity paints a different portrait of what a universe can be. And from these shifting gravitational moods comes a new question. What does space even mean in other realities? Fact 59. What space might mean somewhere else? We think of space as a smooth, silent backdrop, a gentle canvas on which galaxies and worlds unfold. But in other universes, the very nature of space could feel different. It might ripple more easily, like a flexible fabric that sways with passing energy. Or it could be rigid and tightly structured, resisting the curves and bends we take for granted in our own cosmos. Some universes might have additional spatial directions, offering more ways for particles to move. Others might have fewer, creating simpler landscapes where matter can only interact along narrow paths. Each variation shapes the rhythm of existence, influencing how stars form, how planets drift, and how time flows. These differences remind us that even the emptiness between worlds holds its own character, and from the nature of space itself arises the subtle, mysterious flow of time. Fact 60. Time, flowing with a different rhythm. Time, so familiar in our daily lives, may behave very differently in other universes. Here, it flows steadily, carried forward by the expansion of space and the unfolding of entropy. But in another reality, time might move at a different pace, stretching gently, looping softly, or unfolding in rhythms we cannot fully imagine. In a universe with weaker gravity, time could drift more freely, giving cosmic events longer to bloom. In a universe with stronger gravity, time might tighten and flutter, speeding near massive structures and slowing in quieter regions. Some universes might even experience time as a two-dimensional plane, where sequences can spread in more than one direction. Whatever form it takes, time becomes the quiet heartbeat of each universe, guiding its story with a unique and gentle pulse. And from these shifting rhythms, we begin to imagine worlds shaped purely by speculation and wonder. Fact 61. Universes made mostly of water. In the boundless variety of the multiverse, one can imagine universes where water plays a far greater role than it does in ours. Perhaps the laws of physics there make liquid water stable across an enormous range of temperatures, allowing oceans to dominate nearly every world. Planets might drift like shimmering pearls, their surfaces wrapped in endless seas that gently ripple beneath soft, unfamiliar skies. Star systems in such universes might host dozens of water-rich worlds, icy moons, deep blue planets, or warm aquatic spheres where life could bloom in alien shapes. Without vast continents or deserts, ecosystems would weave themselves through currents, tides, and drifting layers of light. These watery realms remind us how profoundly a simple molecule can shape the soul of an entire universe. And beyond such oceans lie places where stars never rise at all. Fact 62. Worlds without stars. In some universes, stars might never ignite. Perhaps gravity is too weak to pull gas into dense, fiery cores. Or maybe the fundamental forces favor particles that don't fuse easily, leaving the cosmos dotted with cold clouds instead of glowing suns. In such worlds, the familiar warmth of starlight is replaced by deep, quiet darkness. Yet even without stars, these universes would not be empty. Giant planets could still form from drifting gases. Moons might gather around them. Heat from geological processes could warm hidden oceans beneath layers of ice. Life, if it arose, might evolve in the faint glow of chemical energy or in the gentle friction of tidal forces. These starless universes whisper a humbling truth. Light is not the only way for existence to unfold, and beyond such darkness lie realms lit by strangers, subtler glows. Fact 63. A realm lit by gentle neutrino. Glow. Neutrinos, nearly massless particles that pass effortlessly through ordinary matter, could play a very different role in another universe. If their properties were slightly altered, they might interact more readily, releasing faint, ghostly glimmers of energy. In such a reality, worlds might be illuminated not by stars, but by soft neutrino light, a gentle, almost imperceptible glow suffusing space. Planets in these realms might have skies that shimmer faintly, as if lit from within. Life could evolve with senses tuned to this subtle radiation, perceiving patterns and movements invisible to us. Galaxies might appear as diffuse halos rather than bright spirals, drifting like luminous fog across the cosmos. These neutrino-lit universes feel peaceful and ethereal, glowing with a quiet beauty unique to their nature. And beyond them, even more exotic cosmic possibilities await. Fact 64. Galaxies of slow-burning blue giants. In some universes, the balance of forces might favor the creation of massive blue stars that burn slowly instead of quickly. Here in our cosmos, blue giants blaze bright and live short lives. But in another reality, their nuclear reactions could unfold in calmer, steadier rhythms. These stars would glow with deep sapphire light, casting a cool radiance across their galaxies. Such galaxies would feel almost serene, filled with vast, graceful spirals illuminated by gentle blue fire. Their longer-lived stars could nurture planetary systems for billions of tranquil years, allowing life to grow under a steady, peaceful sky. The nights on these worlds might shimmer with soft indigo hues, like oceans of starlight stretching across the firmament. These slow-burning giants remind us how delicately star lifetimes depend on the smallest details. And beyond these glowing systems lie even stranger realms. Fact 65. A universe where life breathes methane. Imagine a universe where biology takes a different path, shaped by subtle shifts in chemistry. Instead of relying on oxygen, life might evolve to breathe methane or other exotic gases. These beings would thrive in cold, dense atmospheres, where methane flows like a gentle river of vapor across valleys of ice. Their worlds might be shadowy and dim, lit only by soft reflections from distant stars or chemical glows rising from deep beneath the ground. Plants, if they exist, could absorb chemical energy rather than sunlight, spreading in slow, shimmering patterns across frosted landscapes. Creatures might glide through thick, misty air, sensing their environment through delicate chemical gradients. In these cold, alien ecosystems, life would unfold at a slower pace, yet with its own peaceful grace. And beyond such worlds lie realms woven from even more unusual materials. Fact 66. A cosmos of floating crystal clouds. In a universe with different atomic forces, crystals might not form as solid stones. Instead, they could assemble as airy, floating structures drifting through space. Imagine immense clouds of crystalline petals shimmering like frozen blossoms, each refracting light into soft rainbows. These clouds could drift between stars, pulled gently by cosmic winds or subtle electromagnetic currents. Worlds beneath these clouds might witness skies filled with glimmering shapes, shifting slowly like lanterns guided by invisible tides. Some crystals could grow into intricate fractal forms, expanding for centuries before gently releasing shards into the void. Such a universe would sparkle with quiet beauty, its landscapes painted by delicate mineral light. And from these floating marvels, we wander into realms shaped by winds of magnetism. Fact 67. Realities woven from magnetic winds. In some universes, magnetic fields might play a far more dominant role than they do in ours. Instead of being gentle guides for charged particles, they could become the primary architects of cosmic structure. Vast magnetic winds might sweep across space, shaping nebulae into elongated ribbons or sculpting galaxies into elegant spirals aligned with invisible currents. On planets within such a universe, auroras could fill the skies constantly, shimmering in delicate sheets of violet and jade. Mountains rich in magnetic minerals might hum faintly in the presence of strong cosmic fields, creating landscapes alive with subtle force. Life might evolve senses attuned to these magnetic tides, navigating with ease through patterns we cannot begin to see. These magnetically woven realities show how a small shift can create worlds filled with gentle, unusual forms. And from these structured realms, we drift into universes where time itself behaves differently. Fact 68. A world where time loops. Softly, imagine a universe where the flow of time doesn't march forward in a strict line, but gently loops back on itself in repeating cycles. Events might recur with slight variations, like familiar dreams that unfold again and again with new details. Galaxies could drift through eras that subtly mirror earlier ones, and civilizations might rise with an inexplicable sense of déjà vu embedded in their history. Such a universe wouldn't trap its inhabitants. The loops would be soft and natural, woven into the fabric of space-time. Each cycle would diverge slightly from the last, allowing evolution and change to continue, but always with echoes of what came before. Time in this world would feel like a quiet tide, returning gently to familiar shores. And from these looping currents, we imagine universes bathed in eternal twilight, Fact 69. Planets of endless twilight. In some universes, the balance between star and planet might create worlds where the sun never fully sets or rises. These twilight planets could orbit in such a way that their rotation matches their revolution, leaving one side bathed in eternal dusky glow. The sky would shimmer with soft gradients of rose and blue, creating a landscape that feels perpetually peaceful. Life under this gentle light might adapt to the slow rhythm, blossoming in long, drawn-out cycles. Forests could spread beneath violet skies. Animals might move with unhurried grace, and oceans could reflect a sky that never turns truly dark. These twilight worlds offer a soothing vision of existence, one where day and night blend into a continuous, calming dream. And from this endless dusk, we drift toward the quietest realms imaginable. Fact 70. The quietest universe. Possible. Among the infinite possibilities of the multiverse, there may exist a universe where silence itself becomes the dominant force. In this reality, the early cosmos might have cooled so quickly or expanded so smoothly that almost no structure ever formed. No stars to flare, no galaxies to swirl, no planets to echo with shifting winds. Just a calm, velvety sea of near-perfect stillness. Yet even this quiet universe would not be empty. It would hum with faint quantum fluctuations, like soft breaths moving through the dark. Energy fields would drift gently, creating a cosmos that feels more like a whisper than a world. There is beauty in such simplicity as a universe that exists purely as a calm backdrop to everything else. And from this vast quiet, we return to the idea of boundaries between universes. Fact 71. The soft barriers between universes. If many universes exist, each rests within its own bubble of space-time, separated from the others by expansive regions where the fabric of reality stretches too quickly for anything to cross. These boundaries are not harsh walls, but soft horizons, like the edge of a dream you can sense but never step beyond. They mark the limit where one universe ends and the sea of the multiverse begins. Nothing from our universe, no particle, no light, not even gravity can slip through these expanding partitions. Each cosmos remains peacefully enclosed, protected by the natural flow of inflation and the immense distances that stretch between them. These barriers keep every universe self-contained, nurturing its own story without interference. And from this gentle separation arises a deeper question. Why do universes almost never touch? Fact 72. Why they rarely touch. The reason universes almost never interact lies in the nature of cosmic expansion. Once a bubble universe forms, the space outside it continues inflating at extraordinary speeds, pushing each bubble farther apart faster than light can travel. Even if two universes began close together, the rapidly stretching bulk would sweep them away before their edges could ever meet. This creates a multiverse where encounters are nearly impossible, not because collisions would be destructive, but because the universe simply expands too quickly to allow them. Each bubble floats serenely in isolation, like lanterns drifting on an ever-widening sea. Their solitude is peaceful, allowing every universe to follow its own gentle path through time. And beyond this calm drift, we consider what might happen if two universes did touch, even for a moment. Fact 73. What a collision might look like. Though unimaginably rare, some theories allow for the gentle possibility that two universes might brush against each other in the distant expanse of the multiverse. Such a collision wouldn't be like two solid objects clashing, It would be more like overlapping ripples on a vast, invisible ocean. The fabric of space-time might shimmer, creating patterns of temperature or density that ripple through the newborn universe formed by the impact. From within such a universe, inhabitants might notice faint circular imprints in the sky, cooled or warmed regions left behind by that ancient contact. To them, these marks would feel like cosmic birthmarks, silent reminders of a moment when their reality touched another. It's a quiet, poetic vision, universes greeting one another with gentle, passing waves. And from these hints of collision, scientists turn to the subtle clues in our own sky. Fact 74. Echoes of other universes in our sky. Some cosmologists have wondered whether traces of other universes might be hidden in the glow of the cosmic microwave background, the faint afterlight of the Big Bang. If our universe once brushed another, it might leave behind slight irregularities, a cooler region shaped like a soft circle, or a warm patch that doesn't match the usual patterns of early cosmic noise. These possible echoes would be incredibly faint, blending almost seamlessly into the background. Radiation. Detecting them requires sensitive instruments and careful interpretation, and even then, most signals turn out to be ordinary fluctuations. Yet the idea is comforting, that our universe might carry quiet memories of a time before it fully settled into itself. And among these subtle patterns, one cold region in particular has sparked curiosity. Fact 75. Cold spots as gentle hints. One of the most intriguing features in the cosmic microwave background is a region known as the cold spot. It appears slightly cooler than the surrounding sky, a calm patch in the cosmic afterglow. While many explanations exist, from statistical coincidence to vast empty regions of space, some researchers have suggested it could be a subtle hint of another universe lightly brushing ours long ago. This idea remains speculative, but in a bedtime sense, it's soothing to imagine. A soft imprint left by a neighboring cosmos, like a fingerprint pressed gently into warm clay. Whether or not the cold spot is truly such a mark, it shows how deeply we search for connections across the multiverse. And from these faint clues, we turn toward the quiet mathematics that separates each universe from the next. Fact 76. The mathematics of quiet separation. Mathematics offers a graceful way to describe why universes remain apart. In inflationary models, the equations show that once a bubble universe forms, the space outside it expands exponentially faster than anything inside. This rapid growth acts like a soft but unbreakable cushion, keeping each universe isolated. It's as if every bubble is gently placed on its own expanding island, drifting farther from every other island with each passing moment. The math doesn't create barriers out of force or violence, only out of distance and motion. These subtle relationships define the calm architecture of the multiverse, shaping how each cosmos grows and how it remains eternally distinct. Through numbers and curves, mathematics becomes a quiet storyteller. And from these equations, we look again to the cosmic afterglow for hidden stories. Fact 77. Stories hidden in the cosmic microwave background. The cosmic microwave background, CMB, is a faint, ancient light, the afterglow of our universe's earliest moments. It carries within it delicate patterns, like soft ripples frozen in time. These ripples tell stories of temperature changes, density shifts, and tiny fluctuations that later became galaxies and stars. Some theorists wonder if the CMB might also hide whispers of other universes, subtle distortions, unexpected alignments, or gentle imprints from events older than our own cosmic birth. Most of what we see in the CMB comes from our universe alone, but its quiet texture invites imagination. Each pixel of that ancient glow feels like a door into deeper mysteries, hints of what might lie beyond our cosmic horizon. And as we examine this faint light, we remember that some boundaries can never be crossed. Fact 78. Light that never crosses the divide. Light is fast. The fastest thing we know yet, even it cannot travel from one universe to another. The stretching fabric of space forms a barrier no photon can overcome. Even if two universes rested beside each other, like twin bubbles, the moment space began to expand, the distance between them would grow faster than light could move. This gentle limitation ensures that each universe shines only within its own realm. Its stars illuminate only its own galaxies. Its events, no matter how bright, remain forever unseen by neighboring realities. This cosmic solitude doesn't feel lonely. It feels peaceful. Each universe is allowed to unfold its own quiet story, undisturbed. And from these unreachable distances, we turn to the empty regions that still feel meaningful within our own sky. Fact 79. Empty regions that feel meaningful. Even within our own universe, there are places where almost nothing resides, vast voids stretching for hundreds of millions of light years. These regions contain only a whisper of galaxies, a few lonely clusters drifting in oceans of darkness. To astronomers, voids are simply low-density areas, but in a poetic sense, they feel like quiet pauses in the cosmic symphony. Some wonder whether these empty regions might hold clues to processes beyond our universe, shaped by deeper forces or ancient interactions we cannot yet perceive. Others see them as natural outcomes of cosmic evolution, the spaces between the great filaments of galaxies. Either way, their stillness carries a kind of meaning, reminding us that emptiness can be as beautiful as the brightest star fields. And from this quiet contemplation, we return to the gentle isolation of our cosmic home. Fact 80. The calm isolation of our cosmic home. Our universe exists within its own tranquil envelope, expanding steadily into the unknown. No outside light touches it. No foreign matter drifts in. Everything we experience is self-contained, born from the same primordial fire. This calm isolation isn't restrictive. It's nurturing. It gives our cosmos the space to evolve at its own pace, to form galaxies, stars, and the quiet cradle of life on Earth. As space continues to stretch, distant galaxies drift farther away, their light fading gracefully until it can no longer reach us. Over immense timescales, our universe becomes even more serene, a place where each corner follows its own slow rhythm. This solitude is peaceful, a gentle reminder that every universe, like every life, has room to grow. And within this solitude lies a deeper reflection about ourselves and our place in the multiverse. Fact 81. What it means to be one version of you. In a multiverse of countless possibilities, the idea of you takes on a soft, expansive meaning. Here, in this universe, you follow one particular thread shaped by your choices, your memories, and the quiet flow of time around you. But in other worlds, different versions of you might walk alternate paths, guided by different circumstances or gentle divergences in history. This doesn't diminish who you are. Instead, it highlights the precious uniqueness of your experience. Out of countless possibilities, you are living this one, this moment, this breath, this version of your story. The multiverse becomes a backdrop that celebrates individuality rather than replacing it. Your existence here is a quiet miracle, one branch in a vast, beautiful tree of possibilities. And from this reflection, we drift into thoughts about identity across many worlds. Fact 82. Identity drifting through many worlds. In a multiverse filled with countless possibilities, identity becomes a gentle, flowing concept. Rather than a single, fixed point, you can be seen as a family of selves, each unfolding along its own quiet path. Some versions might share nearly all your memories and dreams, while others might differ in small, subtle ways shaped by different choices, different encounters, different quiet turns in time. These parallel identities aren't in competition. They simply coexist, each one living out a unique expression of what you could be. Like soft reflections in a hall of mirrors, they echo the same source while exploring different directions. This perspective reminds us that identity is spacious, capable of holding multitudes without losing itself. And within this gentle expansiveness lies a comforting thought about chance itself. Fact 83. The comfort of infinite outcomes. Chance plays a tender role in our universe. A breeze drifts, a leaf falls, a star ignites, all shaped by small uncertainties. In the multiverse, every possible outcome continues somewhere, creating a quiet mosaic of realities where all versions of events find a place to unfold. Nothing is wasted. Every possibility is honored with its own story. This idea brings a certain comfort. Instead of seeing life as a series of narrow paths where only one future survives, the multiverse lets us imagine a wider landscape, one where every meaningful possibility gets its own gentle stage. It softens the edges of what if, turning regret into curiosity and fear into awareness. Chance becomes a companion, not a burden. And from this comfort emerges a deeper sense of purpose within an infinite cosmos. Fact 84. Purpose in a place of endless possibility. In a multiverse of limitless worlds, purpose might seem difficult to grasp, yet it becomes even more meaningful. Your choices matter not because they are the only ones you could have made, but because they shape the unique thread of reality you inhabit. Out of endless pathways, you walk this one, infusing it with your presence, your thoughts, and your quiet acts of kindness. In another universe, another version of you may make different choices, but that doesn't diminish the beauty of your journey. Each path carries its own significance, shaped by its own context and moments of growth. Purpose is not defined by rarity, but by authenticity, by living gently, meaningfully, and awake within your own branch of the multiverse. And from this sense of purpose, we drift toward the human wonder that makes the multiverse feel so alive. Fact 85. Why the multiverse feels so human. Despite its vastness, the multiverse resonates with something deeply human. It mirrors our inner landscape, the branching paths of our thoughts, the possibilities we imagine, the quiet alternate lives we sometimes wonder about. Just as the cosmos might contain countless worlds, we contain countless dreams. Each possibility we picture is like a small universe within the mind, unfolding softly behind closed eyes. In this way, the multiverse becomes a reflection of the human spirit. It echoes our curiosity, our longing, our capacity to imagine what lies beyond the familiar. Even though it stretches into infinite realms, it remains intimate because its vastness feels like a natural extension of our own inner depth. And from that connection arises the gentle puzzle of choice and free will. Fact 86. The soft paradox of free will. In a branching multiverse, every choice might lead to its own universe, one where you turned left instead of right, one where you stayed instead of leaving, one where a moment unfolded just a little differently. This can create a soft paradox. If all outcomes happen somewhere, what does choosing truly mean? But rather than feeling overwhelming, the multiverse can bring peace to this idea. Free will becomes the act of experiencing one path fully, even while others bloom elsewhere. You are not responsible for the infinite branches, only for the one you walk. Your intentions, your awareness, your kindness shape the reality you inhabit, giving it weight and meaning. In such a view, free will is not lost. It becomes a gentle, personal art. And from this paradox, the poetry of unreachable worlds begins to shimmer. Fact 87. The poetry of unreachable realms. Some universes, if they exist, will remain forever beyond our reach, not because they are hidden by danger or distance, but because the very fabric of space prevents us from touching them. Yet their inaccessibility adds a sort of quiet poetry to the cosmos. They become like stars seen through a thin veil, beautiful precisely because they are distant, mysterious, and untouched. We can imagine these realms without needing to visit them. Each one becomes a soft metaphor for possibility, a reminder that existence is broader than our senses can grasp. Unreachable worlds invite us to dream, to wonder, and to appreciate the gentle mystery woven into the structure of reality. And from this poetic longing arises the bridge between wonder and understanding. Fact 88. Wonder as a bridge between realities. Wonder is one of the rare experiences that feels the same no matter where it arises. Whether in our universe or some distant realm, the act of looking up or inward with curiosity creates a bridge between the known and the possible. Wonder doesn't need facts or certainty. It thrives in the gentle space between questions and answers, where imagination can drift freely. In thinking about the multiverse, wonder becomes our guide. It lets us picture other worlds, other versions of life, other cosmic landscapes glowing softly beneath unfamiliar skies. Even though we cannot touch those realities, wonder allows us to meet them in spirit, forming a quiet connection across impossible distances. And from this shared sense of wonder, we come to a deeper stillness. Fact 89. The stillness at the center of everything. No matter how many universes there may be, each one contains a center of stillness, a place where motion slows, where light softens, where the vast machinery of nature seems to pause. In galaxies, this stillness might lie in the calm heart between spiral arms. In atoms, it rests in the quiet hum of quantum fields. In the human mind, it appears in moments of reflection, when thoughts settle into gentle order. Across the multiverse, every reality has its own version of this still point, a place where complexity falls into harmony, where the noise of existence fades into a soft, steady pulse. It's a reminder that even amid infinity, simplicity endures. And from this eternal calm, we drift toward the future of multiverse thought. Fact 90. The future and final horizons. Our understanding of the multiverse is still in its earliest stages. New theories, observations, and mathematical insights continue to shape how we imagine infinite realities. As technology improves, we may uncover subtle clues in cosmic radiation, gravitational waves, or patterns hidden deep in the structure of space-time. Each discovery will refine our picture, gently guiding us toward a clearer view. Yet some aspects of the multiverse may remain forever beyond reach, not as limitations, but as invitations to dream. The future of this field lies in a balance between knowledge and imagination, science and poetry. And from these horizons of possibility, we drift gracefully into the final chapters of our cosmic journey. Fact 91. How multiverse ideas may evolve. As our understanding of physics deepens, the multiverse may grow from a speculative idea into a refined scientific framework. Future theories could weave together quantum mechanics, gravity, and cosmic inflation into a single, harmonious picture that naturally gives rise to multiple universes. With each breakthrough, the multiverse shifts from an abstract possibility to a more grounded, elegant explanation of why our universe has the properties it does. Researchers may discover new mathematical structures that reveal hidden patterns in the fabric of reality. These patterns could hint at other universes, even if we can never reach them directly. As our tools and knowledge expand, so too will our imagination, guiding us toward deeper understanding. And from these promising developments arise quiet dreams of discoveries still waiting in the dark. Fact 92. New theories. Waiting in quiet labs. Scientific revolutions rarely begin with noise. They start in quiet rooms, late-night chalkboard sessions, patient calculations, and gentle curiosities shared between researchers. In labs and universities around the world, physicists are exploring fresh ideas, higher dimensional models, new forms of quantum gravity, and theories that might unite all forces into a single graceful equation. Some of these theories may one day reveal natural pathways to multiverse creation. Others may offer alternate visions of reality we haven't yet imagined. Even the ones that don't survive contribute something valuable, a clue, a question, a spark that lights the way for future thinkers. Science moves forward not only through results, but through the quiet dedication of those willing to explore unknown realms. And from this dedication comes the careful study of the cosmos's most delicate signals. Fact 93. Observations hidden in gentle data. The universe speaks softly, and astronomers learn to listen with extraordinary patience. Subtle patterns in cosmic radiation, faint distortions in the shapes of galaxies, or tiny shifts in the timing of distant pulsars may contain clues about the nature of reality at the largest scales. These signals are easy to miss, buried in noise and randomness, but with refined instruments and careful analysis, their gentle messages begin to emerge. Some researchers hope that future observations might reveal indirect hints of other universes, perhaps through signatures of early cosmic interactions or anomalies in the density of space-time. Even if such evidence remains elusive, the act of searching enriches our understanding of our own universe. And from this careful listening comes hope for technologies that might one day explore even deeper mysteries. Fact 94. Technologies that could one day listen. Though we may never touch another universe, future technologies could help us listen more deeply to the quiet structure of our own. Ultra-sensitive telescopes might capture subtle distortions in space-time, while quantum detectors could sense faint patterns in the vacuum itself. These tools wouldn't reveal neighboring universes directly, but they might uncover gentle hints, soft ripples, or delicate asymmetries that whisper of realms beyond our cosmic horizon. We might one day measure the gravitational murmurs left behind by early space-time events, or detect tiny irregularities in the cosmic microwave background that hint at processes older than the Big Bang as we understand it. These observations, even if indirect, could refine our sense of how the multiverse might be woven together. And from these imagined tools grows the expanding landscape of human thought. Fact 95. The expanding landscape of thought. As the boundaries of physics stretch, so too does the landscape of the human mind. The multiverse doesn't only challenge what we know, it challenges how we think. It invites us to imagine realms where the rules are different, where time flows gently in unfamiliar rhythms, where stars hum with alternate forms of light. Each new theory becomes a stepping stone, guiding us to see reality not as a single path, but as a lush forest of possibilities. This expanding landscape of thought enriches not only science, but also philosophy, art, and our private reflections. It reminds us that curiosity is limitless, and that the universe, or the multiverse, is far larger than our early ancestors ever dreamed. And from this growing horizon emerges the simple spark that drives all exploration. Fact 96. The endless curiosity of human minds. Curiosity is our quiet lantern in the dark. It flickers gently in every question we ask, illuminating corners of reality we never knew existed. The multiverse, with all its infinite branches and possibilities, resonates with that curiosity, offering a playground for imagination and a challenge for science. It's comforting to know that even in a universe full of unknowns, our desire to understand remains steady and warm. Each question becomes a thread that connects us to the cosmos, allowing us to explore realms we may never see. In this way, curiosity becomes an unending journey, one that binds our minds to the stars and beyond. And from this restless spark, we drift into thoughts of infinity and why it calls to us so gently. Fact 97. Why infinity will always call to us. Infinity has a way of quieting the mind, even as it opens endless questions. It stretches out before us like a calm ocean with no shore, inviting us to imagine what lies beyond our familiar world. In the multiverse, infinity doesn't feel harsh or overwhelming. It feels soft, spacious, and welcoming. Each universe becomes a gentle wave in an endless cosmic sea, each crest holding a different story, a different balance of stars and possibility. Humans are drawn to infinity because it mirrors our deepest longings, the desire to understand, to explore, and to imagine without limits. Even when we cannot see its full expanse, its presence comforts us. And from this quiet call, we turn to the beauty of mystery itself. Fact 98. The beauty of never truly knowing. There is a peaceful truth in recognizing that some mysteries may never be solved. The multiverse, with all its branching realities and unreachable worlds, may remain partly hidden forever. Yet this uncertainty carries its own gentle charm. It invites us to keep wondering, to keep dreaming, to keep reaching out with our minds even when our hands cannot. Not knowing everything doesn't diminish the cosmos, it enriches it. Mystery adds depth to our curiosity and softness to the questions we ask. It offers us a chance to appreciate the unknown as a companion rather than an obstacle. The beauty of never truly knowing is that it leaves room for imagination to breathe. And from that open space, the multiverse becomes a lullaby. Fact 99. The multiverse as a lullaby. In a sense, the multiverse is a story told by the cosmos, a lullaby woven from possibility and wonder. Its countless universes drift like notes on a gentle breeze, each one humming its own soft melody of stars, atoms, and time. Listening to these imagined harmonies can soothe the mind, easing us into a quieter rhythm where the boundaries of reality feel less rigid and more like the pages of a dream. When we picture endless realms unfolding in the dark, we aren't trying to escape this world. We're learning to appreciate its place in a vast, beautiful tapestry. The multiverse becomes a comforting reminder that creation is plentiful, generous, and endlessly varied. And from this lullaby, we drift into the soft unknown. Fact 100. Drifting into the soft unknown. As we reach the final steps of our journey, the multiverse opens like a serene horizon stretching beyond sight. We may never touch these other realities, but imagining them brings a quiet peace, a sense that existence is richer and deeper than we can ever fully grasp. Each universe drifts in its own gentle rhythm, each carrying its own stars, its own stories, its own possibilities. And here you are, resting in this one, a universe with its own calm beauty, its own night sky, its own soft breath of wonder. The unknown doesn't need to frighten us. It can cradle us, reminding us that mystery is a natural part of being alive. In the soft unknown, we find room to dream. And now, our journey drifts toward its gentle close. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. We've drifted through infinite realities, wandered softly between worlds, and breathed in possibilities as wide and peaceful as the multiverse itself. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your support helps other dreamy travelers find their way to these quiet corners of the cosmos. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.